Hi everyone, welcome back to the Matzo Daddy. So this is going to be part two of angles, which is another Excel topic. So it's a continuation from last week's part one. So let's get right into it.
Okay, so for question 15, they have given that in the diagram, DC sides are 7 sides of a regular inside a polygon, where ABP and HGP are straight lines, but the size of each exterior angle is x degrees and the interior is 7x. Calculate the size of angle GPB, and you need to show your working clearly. So we can say that if we add x and 7x, that would add up to 180 degrees because it's the exterior and the interior. And you can just get x is equal to 180, so that means we'll get what x is a what's the degree of an x, which will be 22.5. And so we already know what's the x, basically exterior angle is x, and we can see that if we want to know the sum of it, we can see that it's going to be 5 sides, so then we just multiply it by 5, which is the sum of the exterior. That would be 180 multiply 5 of all the totals, so that would be a 900. And we want to know the internal, we just have to add up the 180 plus 22.5, so that's gonna end up to 202.5 degrees. And we need to angle GPB. So if you want to know GPB, which is G, P, and B, which is just this side, so it means we're gonna have to find out that because the sum is 900, right, we need minus 2, which is just going to be multiplied by the single x, which is the external 22.5, minus 4 multiply the internal, which is 202.5, because there's 4 internal angles in there. So that's going to be 900 minus 2 multiply 22.5 minus 4 multiply 202.5, because those are the internal angles, so that will give you to 45 degrees. It means this one is 45 degrees. Okay, so moving on to question 16, it says that the diagram shows that the right angle triangle where ABC, this was 90, they've already given the sides, 9 cm, point D, BD, so 3, 23. Calculate the size and decrease to 1 decimal place of angle AC and D. So they want to know this whole thing of AC and D. So it means we can try to find out what the BC is first. So basically we just want to know the length of this. So that means we're going to use tangent 23. And that's like 3 divided by BC, because we want to know BC. So that BC equals to 3 divided by tangent 23, which means you're going to get 7.07 centimeter. And we want to know what's the ACB, what's the whole thing, this whole thing is, so that we can subtract it later. So that it means we're going to have to use cos ACB, and that's equal to 7.07, because it's the this here divided by is a by h, so that's going to be divided by 9, which is hypotenuse 9. So that means ACB is going to equal to 38.2 degrees. So if we just want to know which is ACD, just this thing, we just need to minus it. So angle ACD equals to, the total was 38.2 minus 23 degrees. So that's going to give you 15.2 degrees. And we move on to question number 17. So 17, it says that the diagram shows triangle ABC. The straight lines such as ABD equal to 107 and ECF equal to 58. Calculate the size and degrees of angle BAC. So we want to know BAC one, so this angles is how much it is. So straight on here we can see that this is the opposite alternate, so we can see that it will be 58 degrees. So we can just write that angle ACB is equal to 58 degrees. And then here we can see that it's on a straight line, so that means 180 angle ABC equals to 180 minus 107 degrees, which means it's going to give you 73 degrees. If you want to know, we just know that all the angles in a triangle add up to 180, so that's angle BAC equals to 180 degree minus 58 minus 73 degrees, so that's going to end up giving you 49 degrees. And we move on to question 19. So it says that the diagram here shows that the right angle triangle in which AB equals 15, BC 8, here ACB is 190 degrees. Calculate the size and degrees of 3 significant figures of angle ABC. So we want to know ABC degree. So here we need to try what's the size of the AC first. So it means we need to use hypotenuse rule, which is AC squared equal to 15 squared minus 8 squared. So AC would be equals to square root of 15 squared minus 8 squared. That's going to give you 12.69, rounded off. And after that, if we want to know, we have 90 degrees, right? So we can use the rule sign, the sine rule, which is going to be sine x, because we want to know the x, which is, this is going to be x divided by its angle, its length, which is 12.69, the opposite length, and you need to use sine 90, and the length that is opposite would be 15 centimeter. So if you want an x, you just calculate sine x first. It's going to give you 0.756, and x, you just inverse it, so which means you'll get 49.1 degrees for that angle ABC. You can say angle ABC equals to 49.1 degrees. Okay, so here number 20, it says that in the diagram, triangles ABC and ABD are such that AD equal to BC, to AD equals to BC, and angle BAD, so which is basically this, equals to angle ABC. So you just need to prove that AC is equal to BD. But here we can say that to prove that AC is equal to BD, which is basically this line and this line, we can see that here all of the angles look extremely similar, and you can say that because these are already parallel, which means that these one has to also be parallel when the angles are the same, because in a triangle, if this side is the common side, right? So if this is a common side and these other sides is the same, which means there's no way that this one wouldn't be the same. So you can just write that because the angles are the same, and here there's a common side of AB, it means that all of these sides also have to be the same. Okay, so now for 21, it says that the sum of the interior angles of a regular polygon is 8280. And you calculate the size in degrees of each exterior angle of the regular polygon. So we know the formula of it, so that's 180 degree, n minus 2 equals to 8280, which means 180 n minus 360 equals to 8280, 180 n equals to 3640, which means divide it, you get 48 degrees. And we just need to know exterior. So each exterior angle, that would be 360 degrees divided by 48 degrees. It means it's just going to be 7.5 degrees each. Okay, so now we have 22. So it says that in the diagram, A, B, BD, and D are all three sides of a regular polygon and sides. The point is such that ABC and ADC are straight line, angle BCD equal to 180 degree. Calculate the value of n. So if we look at this, we can see that it is like an isosceles triangle. So it means that these two sides are going to be the same. So that means it's going to be 180 degree minus 150 degrees divided by 2, which will give you 15 degrees each. So these are 15 degrees, and if we want to know this region, we just need to, because it says that we need to find the value of n, right, which means how many sides there are. So we need to find the value of the angle of the polygon, which is just going to be this. That's going to be 180 degrees minus 15 degrees, which will give you 165 degrees. So it means we now just want to know how many n sides are there, which means we can use the formula. So that would be 180 n minus 2 divided by n is equal to 165. 180 n minus 360 equals to 165 n. So that's 15 n is equal to 360, and n is equal to 24. Which means that's going to be 24 sides in there. Okay, so now 23. It says that the diagram shows a right angle triangle ABC in which angle ABC is equal to 90, D is a point of BC such that we've already given the length, and then AD is equal to 18. And calculate the size in degrees to one decimal place with angle CAD. So they want to know this angle again. So it means we need to find AB first. So we need to know this side first to calculate things. So that would be AB squared equals to, you can use two sides, this two, which is 18 squared minus 5 squared. Means AB is just going to be 17.29, which means this side is 17.29. And then we can try to find the whole thing, which is, we can try to find this little thing first, which is DAB, because we have two sides in here. So using sine, we can try to find sine DAB. That's going to be 5 pi, which is basically 18. You can just write it 17. It's going to be, I'm just going to round it off, so that's just going to be close to 16 degrees. And if we want to know angle CAD, we want to know CAD, right? We can use tangent, which is O divided O by A. So that's just going to be tangent. which means if after we find it, that means that we can try to find, or we can try to find the whole thing and then minus this small little thing. So if you want to find the whole thing, we can just use tangent O by A. So it's basically tangent O by A, right? So if it's tangent O by A, that's just going to be, sorry, should I write it this way, but it's just going to be tangent X O by A. That's going to be 8 plus 5. So that's 13 divided by 17.29. And then with that one, you're gonna have to get the tangent first, so that's gonna be tangent inverse 13 by 17.29, right? That's gonna be minus with small ab minus 17.29. So that's just going to be around, sorry, not 17.29, 16. Minus 16 because, yeah, dB. So which means that the angle CAD is just going to be 20.8 around there. It's just a make sure to always take one decimal place, because in angles you do have to take in one decimal places at the end. You have to round off to one decimal places. So now for question number 24, it says using a diagram above, prove that the sum of the angle of triangle ABC is the same as the sum of the angles on a straight line DCE. Give a reason for each stage of your proof. So you can say that angle CAB, that's equal to angle ACD, because we can see that they're going to be alternate angles, and then it's the alternate segment theorem. And you can say that angle ABC, and that's going to equal to angle BCE. So basically these and these going to be equal, and this going to be equal, all because of the alternate segment theorem. Which one you can just write CAB equals angle ACD, and angle ABC equals to angle BCD. Okay, so now going on to 26, it says that figure 1 shows a regular 16-sided polygon in which PA and AB are two sides. Figure 1 also shows that the isosceles triangle AB, which is this is 5 centimeter, PC is a straight line, and you need to calculate the length in centimeter to 3 significant figures of AC. So here we can try to find what C, because it's already set that it says that it's already a 16-sided polygon, which means we can try to find out what's the degree of each side. So that's going to be 360 degree divided by 16, which means it's going to be 22.5 degrees for one side. So if you want to know, we can try to use the formula, which is just going to be, because we already have these two sides, so that's going to be using the cos formula. So that's going to be AC squared equals to 5 squared plus 5 squared, because this 5 centimeter side, minus 2 multiply 5 multiply 5 multiply, you know, the cos, which is cos 180 minus 2 multiply 22.5 degrees, and that's going to give you 9.24 centimeter. So that's just going to be your answer. And we move on to 27. So it says that the angle ABC and D are points in a circle. EDF is the tangent to the circle at point D. Is a tangent, and angle BDF equal to 75. So calculate, giving us its reasons, the size and degree of angle BCD. So we just need to know BCD, that's correct. So we can say that, we can try to find that in this whole thing, if you just need a BCD, right? So it means just, this one's just going to be 75 degrees because it's the alternate segment theorem. So you can say DAB first, yep, equals to 75. That's alternate. And if we want to associate, we know that opposite angles in a quadrilateral add up to 180. So that's just 180 degree minus 75, which is going to be 105 degrees. That's because opposite angles in quadrilateral add up to 180. Quadrilateral in a circle add up to 180. Yep. And we move on to question number 28. Question number 28 says that the diagram shows a regular pentagon ABCDE in 3 sides of a regular n-sided polygon. AB is horizontal while EG is vertical, and DEF is equal to 69 degrees. You just need to calculate the value of n. So to calculate the value of n, because we know that it's a here is a pentagon to the 5-sided, so let's just try to find what's the degree of it, which is 180 degree minus 360 degree by 5 equals to, that's going to be 108 degrees, which we want to know the exterior, which is 180 degree minus 108. It's going to give 72 degrees, and that's the exterior angle. So after knowing the exterior angle, we can try to find the value of n. So that's just going to be, looking at this, we have 69 here, and 72 is the exterior, right? Which means we can use 69 degrees minus 90 degrees minus 180 minus 108 divided by 2 equals to, that's going to equal to 15 sides. So, 15 degrees, which means n, if you want to know, 360 degrees divided by 15, that's going to be 24 sides. So that's just going to be 24 sides here. And moving on to question number 29. It says that in a diagram, ABCD is a trapezium and EDF is an isosceles triangle with DE equal to DF. GAB angle 106 given, so it means this one we just minus it 180, which means it's going to give it 74. And then when you see it, you know that this is also 74 degrees because the lines are parallel, and it means that 180 minus 104, that's get back to 106, and that's going to be 180 minus 106. We just need to know DEF, that's correct, right? Okay, so we'll try to write it down, although you can see it straight away. That angle DAB first, that's 180 degree minus 74, oh sorry, not 74, minus 106 degree, that gives you 74. That's angles on a straight line. Straight line is equal to 180 degrees. And then you can see that angles FDC is also equal to 74 because it's parallel, some parallel lines. And then angle FDE, that's equal to 106, and which is the same as this reason, so I'm not going to write it, the same angle on the same line. And then we know that it's an isosceles, which means angle in the triangle add up to 180 degree, right? So we want to know the two sides. It's 180 degree minus 106 divided by 2, which is going to give 37 degrees. So angles in a triangle add up to 180 degree, and that should be it. So that means that angle DEF is going to be equal to 37 degrees. Yep, and that's it for today's video as well. So I'll see you in the next video as well.